Welcome to Intermediate Algebra, Unit 6, Lesson 1. This is part 1 of 2 videos that deal with the topic of factoring. We're starting with simply removing the greatest common factor. So that is our lesson objectives. And this is very important because any time we factor, we remove the greatest common factor first, and that makes the rest of the problem simpler. So what is factoring anyway? Well, it's kind of like undistributing, or it's the reverse of the process of multiplying. When you multiply two things together, like 5 times 2, each of these is called a factor. 5 is a factor, 2 is a factor, and then when you multiply, we say we create a product, which is 10. So when we factored numbers, there are several things we looked at. One was just writing factor pairs. 10 can be found by 5 times 2. If you take the number 24, you could do 2 times 12, or 4 times 6, or 3 times 8. There are many more factor pairs. And the other thing we looked at was prime factorization. What we do when we factor an expression that has variables in it completely is essentially bring it down to its prime factorization, although the numbers will not need to be in prime factored form. So factoring is just the opposite of distributing, and when we factor trinomials, it's kind of like doing the opposite of the FOILing process when you multiply two binomials together. Instead, you're given the answer and try to figure out which two binomials were multiplied together. So factoring is an important tool for solving equations, and it's necessary to reduce algebraic fractions. When you reduced fractions with numbers like 2/10, you reduce that to 1/5 because the top had a factor of 2 and the bottom had a factor of 2. 2 times 5, so it left a 1 on the top and a 5 on the bottom. We can do the same thing with algebraic expressions, it just looks a little different. So the way we factor completely, we're only going to work with this first step here of bringing out the greatest common factor, but then we're going to look for other patterns to get to that completely factored form. So factoring is just the reverse of multiplication, and the first thing we always use in any technique is to try to factor out any common factor. If we look at the expression in example 1, 4y squared plus 8, I can see that 4y squared can be written as 4 times y squared, and 8 can be written as 4 times 2. Now there were two terms in our expression, 4y squared plus 8, the plus separates terms, and what we're looking for is in each of those terms, is there any factor they have in common? In this case, the 4. So I have a 4 and I have another 4. So I can undistribute that 4 and place what's left in parentheses. Now by what's left, notice this is y squared. The 4 is on the outside. If I take 4y squared and divide it by 4, that tells me what to put in the parentheses if I've written the 4 on the outside. Again, if I take 8 and divide it by 4, that tells me I need a 2 on the inside because I already have the 4 on the outside. The way you check this work is to distribute the 4 through these two terms and see that you come out with what you started with. So here's another example. Now you'll see in this one there's a number that is part of the greatest common factor, but the variables can also be part of a greatest common factor. I have 5x to the 4th minus 20x cubed. Well, x to the 4th can be written as x to the 3rd times x. And over here, 20 can be written as 5 times 4. So the two terms are separated by subtraction here, but both terms have a 5 as a factor, and both terms have an x cubed as a factor, so I write that out in front of some parentheses. Then inside the parentheses, I will still have two terms, but they will be my original terms divided by 5x cubed. So 5x cubed times x over 5x cubed leaves me with the x, and in this term I'm left with the 4. So that is removing the greatest common factor there. It will be true that if you have variables that match, you will be able to remove, if the variable is in every term, not missing, if there'd been a number like a plus 12 at the end of this or something, I actually wouldn't have had any common factor. But even if I had a plus 5 at the end, if there's no x, then I couldn't pull any x's out. But if you have x's in every term, or a variable in every term, you can remove the variable with the smallest exponent. In this case, 3 is smaller than 4, so we could remove an x cubed, because larger exponents can be written as a product of the smaller exponent with another variable. So for our third example, we have numbers and letters again. And you can see 15 and 12 have a common factor of 3. Y to the 8th and y to the 4th. There is a y to a power in both of my terms, or in all of my terms. And 4 is smaller than 8, so y to the 4th is part of the greatest common factor. And remembering the rules of exponents, if I were to do y to the 8th divided by y to the 4th, it would leave me with y to the 4th for the inside. And 12y to the 4th divided by the 3 gives me the 4. So we have a common factor of 3y to the 4th. Alright, so now we want you to try these. Take a look at these, stop the video, freeze it so you can see these. The answers are on the next slide. So stop the video, and when you come back, we'll go over the answers. Okay, hopefully you actually did stop the video. So for our first problem, we should have found a common factor of 3x. If I multiply this out, I don't have the ability to write on this as I do it, but if I multiplied this out, I would get 3x times x is 3x squared. 3x times 2 is 6x. So I would get 3x squared minus 6x. And that indeed was our first problem. So you can check the rest of these similarly. Number 3 is a little tricky, because if you look at problem 3, the first term had only a capital P in it, and the next term had a capital P with some other factors. If the only part of the term is the common factor, you have to put a placeholder of a 1 there. This is really P times 1, just as this is P times R times T times 1, but when there are other factors, we don't write the 1, because if you don't put the 1 there, it's implied to be a 0, and you won't be able to multiply back and distribute the P and get back the original problem. And number 4 here had a common factor with a number and a letter, and we had 3 terms. But what you should see is the third term also had y squared in it. If the third term did not have a y in it, it couldn't be part of the common factor. Alright, so here's another example with 2 variables. We have the common factor numerically will be a 4 from the 12 and the 20. I have an x in both terms and I have a y in both terms. The x shows up, the smallest power is a 2, and the y in both terms, the exponent is a 1, which is implied. We don't write it. So my common factor is 4x squared y. If I divide the first term by 4x squared y, I get a 3. If I divide the last term of my problem by 4x squared y, I get 5x. That's where these two come from. So this one looks even more complicated maybe, but really it isn't if you just follow the process. You have a 10, a 4, and a 2 as the coefficients in each term. They have a common factor of 2, so that's the number you can pull out. Then you have p in each term. The smallest exponent is a 4, so a p to the 4th goes on the outside. Q shows up in every term, and the smallest exponent is a 2, so that goes on the outside. To get what's left inside, you take each of your original terms and divide by the common factor, and you're left with p squared minus 2pq plus q squared. So here are a couple more for you to try that are similar to what we just did. Again, stop the video, write out the problems, and we'll take a look at the solutions when you come back. See you in a minute. Okay, here are our answers. Hopefully you really did stop the video. So if I multiply out number 5 here, I should get 20p cubed r plus 12p squared r. And that is my original problem, so that's correct. And again, if I multiply out number 6, I should get my original problem back. And it looks like I did. So that's good. If you got those right, you're getting the idea. Alright, that's all for this edition of Math Teacher to Go and Intermediate Algebra Lesson Unit 6, Lesson 1, Part 1 of 2. We'll see you in Part 2.